Welcome to wasrats.com. Let's start a topic from chemistry. So let's see that what we are going to learn in this video. So the topic which we are taking in this video is carbon and its compound part 4. As you have already done the part 1, part 2 and part 3. In part 1 we did the basic, you can say the information related to hydrocarbons, that is the saturated and unsaturated. We also learned about making the members of like the different functional groups and also the saturated and unsaturated. In part 2, what are the chemical properties of the functional groups, and in the third part we learned about the chemical properties of alkanes, alkenes and alkynes. So let's see that what we are going to take in part 4 of carbon and its compounds. So the topic which we are going to cover in this video, that we'll do some question and answers. So let's start with it. So the first question is, define formaldehyde and also write its one use. So the first thing is, formaldehyde is the member of aldehyde and it is the first member of aldehyde, that is, it is called as HCH. And what's its IUPAC name? Its IUPAC name is methanol. And as far as its common name is concerned, it is called as formaldehyde. Right? So, what is formaldehyde? Formaldehyde is the first member of aldehyde, that is HCH. So, this is the molecular formula for formaldehyde. We can also condense it more and write it as CH2O. So, this is what is formaldehyde. And now we need to write its one use also. Formaldehyde is commonly converted into formalin, right? So how it is converted? Formaldehyde, to formaldehyde we add water, a specific percentage of water, and due to which we get formalin. And formalin has an important use in labs as it is used for storing the specimens in lab, as it is used in storing the specimens in labs. As you must have noticed in your bio lab that there are certain specimens, the insects, the rats and other organisms, they are stored in the container which is filled by the watery fluid. That watery fluid is not water, it is actually formalin that resembles water, but actually it's not water, it is quite thicker in its viscosity and it is called as formalin. It acts as a preservative and that is the reason it is helping in storing the specimens. Another question is, explain esterification. So the first thing is that we are going to define that. So what is esterification? Esterification is the process of formation of ester. It is the process of formation of ester, and from which substances the ester is formed. So it is the process of formation of ester from alcohol and carboxylic acid. From alcohol and carboxylic acid. And one necessary condition which has to be there is in presence of concentrated sulfuric acid, which act as a dehydrating agent in this reaction. So what is the general reaction involved? It is the alcohol plus carboxylic acid in presence of concentrated sulfuric acid, and what do we get to see? That we get ester plus water. So this is the general reaction. And what is the identification property which shows that the ester is formed or the reaction has taken place? After we mix alcohol and carboxylic acid, when they react, we come across a fruity smell, and that fruity smell indicates that the reaction has taken place. Now let's take up few examples and show this reaction. So let's say we have methanol, right, and we have ethanoic acid, right. Let's say it is occurring in presence of concentrated sulfuric acid. So what we'll get to see that we know ester is RCOOR. So this is going to be R and this is going to be RCOO. So when we link them, we get CH3, COO, CH3, and this OH and then this H is removed as water. So this is how the ester is formed. How you're going to name it? One alkyl group, the smaller alkyl group, is treated as the alkyl group. So what do you write? You write its name as alkyl, that is methyl in this case. Then you add both the carbons, or in the carbons which are left. So 1 and 2, it means eth. An will be primary suffix, OH will be the secondary suffix for the ester. So it becomes methyl ethanoate. Or it can be written as 2-propanoate, because at 2 position you get to see CO group. So it can also be called as 2-propanoate. So common name is methyl ethanoate and IUPAC name is 2-propanoate. So this is what is esterification. Third question is, write the equation involved in the formation of ethanol by alcoholic fermentation process. So first we are going to define that what is fermentation. Fermentation is the breakdown of complex substance into simple substance. And how it breaks up? It breaks up by the action of enzyme, released by microorganisms. And this method is basically used for the formation of ethanol, and where it is taking place in breweries, right? Because we know that the ethanol is the major content, or you can say it is the major percentage which is present in the hard drinks. So how we form it? We take a sugarcane juice, to it we add water, we heat it, and we get a thick sweety substance, which is sweet, and that is called as molasses. So which sugar is present in sugarcane juice? That is sucrose. So this is sucrose plus water. So this is what is molasses, right? So the microorganism in it is yeast, and the enzyme it secretes is invertase. So this invertase converts this complex sugar into simple one, that is glucose and fructose. This we have already discussed, that both the sugars possess same formula, but they differ in many properties, like they differ in the optical activity as well. But this is not the simplest sugar. We can convert into more simplest form. These secrete the another enzyme that convert into the simplest substance, that is ethanol and carbon dioxide. So this is how that the ethanol is formed in breweries by alcoholic fermentation process. Next question is, when propanol, that means alcohol, is reduced, which substances form? We know that reduce refers to reduction, and reduction means addition of hydrogen. So basically what is asked, that when alcohol is reduced, what do we get? We know that when we oxidize alkane, we get alcohol. When we oxidize alcohol, we get aldehyde. When we oxidize aldehyde, we get carboxylic acid. And the opposite is the reduction. So that means when we are reducing alcohol, it is transforming into alkane. And there can be certain reducing agents also involved, like nickel, platinum, palladium, like that. So alcohol transforms into alkane, and we also know that it is neither step up nor step down reaction. So let's focus which alcohol is asked. That we have propanol. Let's write its formula. So what is propanol? Propanol is C3H7OH. We are adding hydrogen. So what we'll get? We'll get the respective alkane. So we are doing for propanol. So that means we'll get propane. So we get propane, and along with propane, what do we get? We get water. So that means when we reduce propanol, what do we get? We get propane. So propane is the right choice. Another question is, what are the products formed when ethanol undergoes complete controlled oxidation and uncontrolled oxidation? We know that oxidation is basically of two types. One is uncontrolled and other is controlled. Where the uncontrolled oxidation refers to combustion, that is burning anything, and whenever we are carrying out uncontrolled oxidation of any hydrocarbon, like in this case we have been asked for ethanol. So in spite of ethanol, I'm talking about every hydrocarbon. So it is for ethanol also and for other other compounds also. So if we have ethanol and we are carrying out its combustion, which takes place in supporter of combustion. So what do we get? We get carbon dioxide, water vapor and energy in the form of heat and light. So this is what is formed when it undergoes uncontrolled oxidation. Now let us talk about the controlled oxidation. Controlled oxidation means we are oxidizing it, either we are reacting it with nascent oxygen or a complete molecule of oxygen in presence of catalyst or an oxidizing agent, which doesn't let it undergo combustion, it just oxidize it and lead to the formation of some other organic compound. So alcohol shows, like if I talk about ethanol, they show two types of oxidation. One is partial, where they react with nascent oxygen. Other is complete, where they react with the alkaline KMnO4, or it can be potassium dichromate. So when it is partially oxidized, any alcohol which is partially oxidized, we get aldehyde, the respective aldehyde, the same aldehyde with the same word root. And if it is completely oxidized, we react with O2 in presence of oxidizing agent alkaline KMnO4 or K2CR3, it forms decarboxylic acid. So let's complete. We have ethanol. On partially oxidizing, it will form an aldehyde. Ethanol will change into ethanol. So that means we will have CH3CH. And when it is completely oxidized, it will form the respective carboxylic acid. That is, ethanol will form ethanoic acid, which is CH3COOH. So this is what is ethanoic acid. Another question is, how can we convert ethanol to ethanoic acid? How can we convert propanol to propane? How can we convert ethane to ethanol? So let's take the first one first. We have to convert ethanol into ethanoic. So whenever this kind of question is given, so take them in a general form. We know that ethanol is alcohol, and we know that ethanoic acid is carboxylic acid. So you need to convert, in the first case, alcohol to carboxylic acid. You know that it can be easily converted by carrying out the complete oxidation in presence of alkaline KMnO4 or K2Cr2O7. So that means if you have ethanol and you need to convert into ethanoic acid, it can be converted by complete oxidation, that is by reacting with oxygen molecule in presence of alkaline KMnO4, or you can write K2Cr2O7. So this is how you convert ethanol to ethanoic acid. Now let's take the second one. We have to convert propanol to propane. So in general, it is alcohol and it is alkane. So how can we convert alcohol to alkane? Obviously, we can convert alcohol to alkane by carrying out its reduction, which means the addition of hydrogen, and it can be in presence of certain reducing agent. Right, and the carbon atom remains same. So if I say if I have ethanol and I need to convert, we have been asked for the propanol. So we have C3H7OH, that is propanol. We have to reduce it, that is reacting with hydrogen in presence of nickel or any other reducing agent. It will transform into propane, alkane, that is propane. Propanol will form propane, and along with that we get. So this is how we convert propanol to propane, or we can say alcohol to alkane. Third, we need to convert ethane to ethanol. Ethane is alkane and ethanol is alcohol. Right, so that means it is opposite to reduction, which is called as oxidation. So we can convert alkane to alcohol. How? By oxidizing. And how we oxidize? Like we know that if we wanted to convert into alcohol, we make use of copper. And if we want to convert into aldehyde, we make use of molybdenum oxide. And if we wish to convert into carboxylic acid, then the catalyst uses silver oxide. Here we are asked to convert into alcohol. So we'll use copper as a catalyst. So that means if we have ethane, we have been asked to do for ethane. So it is ethane, we are oxidizing it and the reaction is being carried out in presence of copper. Then we get alcohol, that is ethanol. So this is how we carry out the conversions. So whenever any conversion is asked, please make sure that you look for the general formula, remind the general property, and then apply that on the asked question. Another question is, when the hydration of propene occurs, which compound is formed? Hydration of propene, Propene is an alkene. So here we have been asked that hydration of alkene forms which product? We know that hydration of alkene means we are adding water to alkene, and when we add water to alkene, it forms respective alcohol. And this reaction takes place in presence of concentrated weak acid like phosphoric acid. So obviously alkene forms the alcohol in this case. Now in this question particularly we have been asked for propene, which is C3H6. So obviously if you add water to it in presence of concentrated acid, it will transform into alcohol. So this is propene, so it will form propanol. This is propene, it will form propanol due to addition of this H2O. Right, so out of it, which is going to be the major product? So we have alcohol, we have carboxylic acid, propanol and propanoate. So in general, it will form alcohol. So this is how you're going to carry out and answer these kind of questions. Another question is, write the first member of ketone and ester. So first let us write their functional group. So if we write about ketone, the functional group of ketone is CO, and for ester it is COO. And the similarity between them is that they always possess alkyl group on their either side, so both of them. So that means the first member need to possess minimum 3 carbon atoms. So the first member of ketone will be CH3COCH3. That is propanon, or propanon, whatever you think. And for ester, it is going to be CH3COOCH3, again at least with 3 carbon atoms. So it is going to be CH3COOCH3, which can be called as methyl ethanoate, or it can be called as 2-propanoate. So these are the first members of ketone and ester. Now write the common names for the following. We need to write the common names. These are the IUPAC names, and we need to write their common names. So for ethanol, the formula we know is C2H5OH, and the common name is ethyl alcohol. The common name is ethyl alcohol. Ethanol we know is CH3CHO, right? And the common name for it is acid aldehyde. It is acid aldehyde. Ethanoic refers to CH3COOH, and the common name for it is acetic acid, also called as vinegar. Propanon is CH3COCH3. This is what is propanon, and the common name for it is acetone, which is a major constituent of nail polish removers. So this is acetone. Methanoic acid refers to HCOOH, and the common name for it is formic acid. Formic acid. Methanol refers to HCHO, and the common name for it is formaldehyde. It is very important to remember these common names, because sometimes the situation arises that in a paper you get a question not from the IUPAC name. Instead of that, the common names are mentioned. So if you're not aware of the formaldehyde, formic acid, or any common name, so how you're gonna perform the reaction? So it is important that you have to remember the IUPAC name, and at least these common names should be remembered by. Another question is alkaline potassium permanganate. That means we have been asked something about alkaline KMnO4. Is an oxidizing agent, pain relieving agent, reducing agent, or both A and B? It is an oxidizing agent. As you know that it is used in the complete oxidation. For example, if you have any alcohol and you are oxidizing, get complete oxidation, and you are using alkaline KMnO4, it oxidizes the alcohol and it forms the respective carboxylic acid. Let's say if we have ethanol, it gets oxidized in presence of alkaline KMnO4 and leads to the formation of ethanoic acid. So it acts as a powerful oxidizing agent. Another question is, we need to write the molecular formulas for the following compounds. So the first compound is ethanol. Eth means 2, so that means it is a compound with 2 carbon atoms, and Al refers that it is an aldehyde. So that means it is CH3CH. Methanol, met means 1 carbon atom, Al again refers to an aldehyde, that means it is a first member of aldehyde, that is HCHO. methanoic acid, meth refers to 1, oic acid, that means carboxylic acid. So it's the first member of carboxylic acid, that is HCOOH. Propanone, prop refers to 3, un refers to ketone. You know that the first member of ketone is propanone, that is CH3COCH3. The another is methyl ethanoate. Now this time we have the common name, but we know that methyl is going to act as alkyl group, eth means the R group, and OAte refers to the ester. So we have CH3, right, ethanoate, that means we have the ester group COO, and eth means here we have CH3, because this forms methyl and these two carbon atoms will form eth and OAte for COO group. So the formula is CH3COOCH3. Again, we have a question that we need to define denatured alcohol. So what is it? Denatured alcohol is to alter the nature of alcohol. What we do in industries, we add certain poisonous substances to it. We add certain poisonous substances to it in order to prevent its misuse, by workers of industries. So that means we are altering the nature of alcohol by adding certain poisonous substance which make it unfit for drinking purpose, and it prevents its misuse by workers of industries. And what substances do we add to make it denatured? Let's name two substances. One is pyridine and even one alcohol, that is methanol. Methanol is an alcohol, but if this alcohol is is added to the you can say there in the alcohol, it make it denatured, or because its nature is poisonous. Another question is that we have to complete the following reaction. So the first reaction is ethanol plus O, and O is nascent. So that means alcohol is undergoing a partial oxidation, and we know that whenever ethanol undergoes a partial oxidation or any alcohol undergoes a partial oxidation, it forms the respective aldehyde. So what we'll get, ethanol will transformed into ethanol, that is CH3CHO, and the catalyst which we are used in making it partially oxidized is chromic oxide in acetic acid, right? So this is what is the complete reaction. In another reaction, what do we have? We have an aldehyde, and it is H2 is being added. That means it is undergoing a reduction. So whenever aldehyde undergoes a reduction, it forms alcohol, right? And the alcohol contains the same number of carbon atoms. So ethanol will transform into ethanol, that is C2H5OH. So this is how you're going to carry out the reactions. This is my one advice to you, that whenever you are learning this chapter, please focus on the general equations and then try to frame the formulas. If you will do in this manner, then you won't forget any reaction, and even you won't get confused also. Another question is, what are the products formed when CH3COOH react with NaOH? That means carboxylic acid reacts with metal hydroxide. You know that Na will replace H in this case, and we'll get CH3COONA, and this H and OH is left, so we'll get water. And what is the name of the compound? This is sodium ethanoate. In another reaction, we have again an acetic acid and we have metal carbonate. So again, Na will replace H, we'll get CH3CONA, and along with that we'll get water and carbon dioxide. So whenever any carboxylic acid reacts with metal hydroxide, metal carbonate, or metal bicarbonate, the same product is formed. That metal replaces hydrogen and we get metal alkanoate, depending upon the member which is used. Another question we have, convert butanoic acid to propane. So when we have to convert the carboxylic acid to alkane, we can directly do by the process or a reaction which is called as decarboxylation, because decarboxylation refers to the removal of carboxyl group, right? So how we do it? We take a carboxylic acid, let's say in this case we have butanoic, so let's use the butanoic acid for it. So we know but is 4 carbons, right? Oic acid means this one will act as COH. Let us stabilize their valencies. This is what is butanoic acid. We are going to react with metal. Metal will replace H, and as a result we will get CH3, CH2, CH2, COONA. Right. Then to this compound, let me condense it. It is C3H7COH. Right. I have added all those hydrogen and carbons. And to it we add sodium hydroxide. And when we add like this, so what happens? This actually breaks in this form. This H attaches to this R group and form alkane. So it will be C3H8. That is propane. And always like whenever the decarboxylation occurs, the side product which is formed is sodium bicarbonate by this. So this is what is decarboxylation and a method to convert butanoic acid to propane. Thank you for watching this video, and for more learning experience, please visit to www.courserax.com. So with this, we finish the chemistry of carbon compounds.